Okay, this is Dr. Williamson. Let me see if I can explain how to do this lab. So in this lab, we have our copper salt, which is this stuff right here. Okay. That's, you guys made that before. We're going to put 0.15 grams of that. You're going to measure it accurately to 4 decimal places. But, we're saying about 0.15 grams, and you're going to know how much of that. We're going to put that into a beaker. Then we're going to pipette into that accurately. We're going to pipette into that accurately 50 milliliters. Okay, this is supposed to say milliliters of our 0.12 molar hydrochloric acid that we made in the beginning. We're going to make 0.12 molar hydrochloric. And we're going to make 0.12 molar sodium hydroxide. Okay. The XX means we don't know their exact concentrations yet. We're going to figure that out after the fact. Okay. Keep your solutions. If you mess up and pour it out, you got to start the experiment all over again. So we're going to take our 0.12 something something molar hydrochloric. We're going to add 50 mils of that. We're going to pipette it to 2 decimal places to our salt. And when we do that, we're going to add, this is going to be 0.12 XX millimoles per milliliter. So we're going to get 6.0 XX millimoles of HCl total that we've added into here. Some of that HCl will react with this. So out of that 6 millimoles of HCl, less than 6 will react with this stuff because of the ammonia that's in there. So let me kind of draw this. Cu and H3 4 SO4 dot water plus HCl right? It's going to react. The H plus on this is going to react with the lone pair of electrons on here. And we're going to get Cu and H3. I'm not done. With a 4 SO4 dot H2O with a single H2O. What am I doing? H2O. And I have an H plus on here. Plus chloride ion floating around as a spectator. So out of that 6 millimoles, let's say 4 millimoles reacts with it. I'm just making up a number. I would have 2 millimoles left floating around unreacted in here. Okay, just making up numbers here, not saying that's what it is. Okay, then when I titrate with my sodium hydroxide, I'm going to titrate and find out how many millimoles are floating around free. Okay, so if I know the total millimoles from this, that's going to be equal to the reacted plus the free. If I know the total from here, and I know the free or the unreacted from the titration, I'll then know, right, the amount that was unreacted. If I know the amount that, excuse me, I'll know the amount that was reacted. And if I know the amount that was reacted, the millimoles that was reacted, I will then know the millimoles of ammonia that was in the salt. Because for every millimole of ammonia, NH3, you want to call it ammonia, for every millimole of NH3 in the salt, 1 millimole of H plus hydrogen ion will react. So then I will know the millimoles of NH3 that's in the salt. And if I know the grams of the salt, I can figure out the millimoles of the salt. And so I will be able to get the, let me do this, you have to do some thinking, but I will then be able to get the, let me erase this, guys. This is the select button. Let me erase this. Erase that. Okay. Oh, I erased more than I intended. But anyway, let me go back to here. Green's a good color. So then, from my grams of salt, I will be able to calculate the millimoles of salt, of the salt, because I know the molar mass of the salt, because it's this stuff right here. And from this, I know the millimoles of the ammonia. So I'll be able to do millimoles of NH3. I suppose I should call it NH3, not ammonia. Ammonia when it's a free substance. But I'll do the millimoles of NH3 divided by the millimoles of the salt. And that'll let me get the percent NH3. I keep calling it ammonia. Let me get the percent NH3. I'll have to multiply that by 100. Okay. That's the hard thinking part. But what you have to do afterwards, okay, what you have to do afterwards, let me erase this stuff. Watch, I'll probably need that once I'm done. Once you've done the titration, before you do these calculations, remember you made, let me do this beaker. Let me do that beaker. And over here, you made 0.12 XX molar HCl. Oh. And over here, you made 0.12 XX molar NaOH. You have to go back and titrate these, and you have to figure out, well, not figure out, but you have to calculate and determine, I guess figure out's the right word. You have to determine the actual values of these next two decimal places. You do this one by titrating this against KHP solid. You've done this before. You're going to do that by titrating that against KHP solid. And then you will titrate this hydrochloric acid against that separately. So this is a complex and involved lab, and it's not easy. So you'll have to do a lot of thinking. Okay? And so, you know, I've done as much as I can to help you, but all this is intended to be a courtesy to the students to help you, you know, kind of go the extra mile. Not to, you know, it's kind of intended to be students are supposed to do the lab without all this extra help, but I can't help it. I'm kind of soft-hearted. Okay, then I hope that helps.